Welcome to Professor Benzene. This is Professor Benzene. Today we are discussing the eighth part of the solutions to NCERT questions of the second chapter of class 11 chemistry, structure of the atom. In this video we will discuss solutions to exercise questions 49 to 53. So let's begin. 49th question is lifetimes of the molecules in the existence states are often measured by using plus pulsed radiation source of duration nearly in the nanoseconds range. If the radiation source has the duration of 2 nanoseconds and the number of photons emitted during the pulse source is 2.5 into 10 power of 15, calculate the energy of the source. एनर्जी निकालनी है, ड्यूरेशन दिया हुआ है और उसका फोटॉन्स का नंबर दिया हुआ है 2.5 into 10 power of 15. तो कैसे निकालेंगे? वी नो फ्रीक्वेंसी of radiation equals to inverse of time, so which is 1 upon 2.0 into 10 power of minus 9 seconds, because it is in nanoseconds, so it becomes frequency equal to 5.0 into 10 power of 8 seconds inverse. Energy equals to nh nu, n is number of photons, h is Planck's constant, n is frequency, mu we calculated, n is given, h we know, putting on all the values, e equals to 2.5 into 10 power of 15 into 6.626 into 10 power of minus 34 joule seconds into 5.0 into 10 power of 8 seconds inverse. We get 8.282 into 10 power of minus 10 joules. That is the energy. Next question. The longest wavelength doublet absorption transition is observed at 589 and 589.6 nanometers. Calculate the frequency of each transition and energy difference between the two excited states. Wavelength or energy difference between the two states. So wavelength associated with the first transition is lambda 1 is 589 nanometer, which is 589 into 10 power of minus 9 meters. Lambda 2 is 589.6 nanometer, which is 589.6 into 10 power of minus 9 meters. Frequency of the first wavelength nu 1 equals to c upon lambda 1, which is 3 into 10 power of 8 meter per second upon 589 into 10 power of minus 9 meters, which is 5.093 into 10 power of 14 seconds inverse. For second wave frequency, nu 2 equals to c upon lambda 2 equals to 3 into 10 power of 8 meter per second upon 589.6 into 10 power of minus 9 meters. It is 5.088 into 10 power of 14 seconds inverse. Energy difference कितना है? Delta E equals to h nu 1 minus h nu 2, that is delta E equals to h times of nu 1 minus nu 2. So we have 6.626 into 10 power of minus 34 into 5.093 into 10 power of 14 seconds inverse minus 5.088 into 10 power of minus 14 seconds inverse. It is 3.31 into 10 power of 22 joules. So energy difference is 3.31 into 10 power of minus 22 joules. Next question. The work function of cesium atom is 1.9 electron volts. Calculate the threshold wavelength and the threshold frequency of the radiation if the cesium element is radiated with a wavelength of 500 nanometers. Calculate the kinetic energy and the velocity of the ejected photoelectron. So we know that work function is given 1.9 electron volts, and we know work function equals to hc upon lambda naught. So lambda naught equals to hc upon w naught. Threshold wavelength we can calculate from here equals to 6.626 into 10 power of minus 34 into 3.0 into 10 power of 8 upon 1.9 into 1.602 into 10 power of minus 19 to convert electron volts into joules. We multiply by 1.602 into 10 power of minus 19, and we get lambda naught equals to 6.53 into 10 power of minus 7 meters. Hence threshold wavelength is 653 nanometers. Next part is the threshold frequency of the radiation. Now we calculate nu naught, which is w naught minus h nu naught. So nu naught equals to w naught upon h. So we know nu naught, and we can calculate substituting the value we get nu naught equals to 1.9 into 10 power of in 1.9 into 1.602 into 10 power of minus 19 upon 6.626 into 10 power of minus 34. So it becomes nu naught equals to 4.593 into 10 power of minus 14 seconds inverse. Hence threshold frequency is 4.593 into 10 power of 14 seconds inverse. Now wavelength used in irradiation lambda equals to 500 nanometers, kinetic energy equals to h nu minus nu naught or hc 1 upon lambda minus 1 upon lambda naught. So h we know, c we know, and simplifying this 1 upon lambda minus 1 upon lambda naught, we get lambda naught minus lambda upon lambda into lambda naught. Putting in all the values, 6.626 into 10 power of minus 19 into 3.0 into 10 power of 8 in bracket 653 minus 500 into 10 power of minus 9 because both are in same power upon 653 into 500 into 10 power of minus 18 meter square because this time power will add up. So it becomes on calculation 9.3149 into 10 power of minus 20 joules. Kinetic energy of the ejected photon is 9.3149 into 10 power of minus 20 joules. Since k equals to half mv square equal to this much, so we can calculate v from this. V equals to under root of 2.0451 into 10 power of 11 meter square second minus 2, and we get velocity equals to 4.52 into 10 power of 5 meter per second. Next question. Following the results are observed when sodium metal is irradiated with different wavelengths. Calculate threshold wavelength and Planck's constant. तो threshold wavelength यहाँ निकालेंगे. Assuming that the threshold wavelength to be lambda naught nanometer, lambda naught into 10 power of minus 9 meters, the kinetic energy of the radiation is given as h equals to nu minus nu naught equal to minus half mv square. The three different equalities can be formed with the value given as hc equals to 1 upon lambda minus 1 upon lambda naught equal to half mv square और hc equal to जो डिफरेंस है दोनों का 1 upon lambda minus 1 upon lambda naught, जस्ट लाइक द प्रीवियस क्वेश्चन. उस फॉर्म में लिख देंगे, सारी वैल्यूज पुट कर देंगे. h पता है, c पता है, लैम्डा गिवन है, तो यहाँ इसको वैल्यूज रखेंगे. एच सी इक्वल्स टू 1 upon 500 into 10 power of 9, 1 upon lambda naught into 10 power of minus 9 equals to half m. V is 2.55 into 10 power of minus 5 into 10 power of minus 2. इसको कैलकुलेट कर लेंगे, दूसरी वैल्यूज रख लेंगे. दिस टाइम 150, द सेकेंड वैल्यू विच इज 450 एंड द थर्ड टाइम 400. सो लैम्डा चेंज करते जाएंगे, लैम्डा नॉट विल रिमेन सेम, और 3 इक्वेशन बन जाएंगी. उसके बाद थर्ड और फर्स्ट इक्वेशन डिवाइड कर देंगे. सो वी विल गेट लैम्डा नॉट माइनस 400 अपॉन 400 लैम्डा नॉट डिवाइड बाय लैम्डा नॉट माइनस 500 अपॉन 500 लैम्डा नॉट. इसको सिंप्लीफाई कर लेंगे तो ये बन जाएगा 5.35 into 10 power of 3 मीटर पर सेकेंड स्क्वायर होल स्क्वायर अपॉन 2.55 into 10 power of 3 मीटर पर सेकेंड होल स्क्वायर. फर्दर सिंप्लीफाई कर लेंगे तो यहाँ से हमको एक वैल्यू मिल जाएगी लैम्डा नॉट की, विच इज़ 539.8 नैनोमीटर्स. नाउ लैम्डा नॉट इज 539.8 नैनोमीटर, it is can be assumed to be 540 nanometers. So threshold wavelength is 540. And second part has not been solved because of incorrect values. Next question. The ejection of the photon from the silver metal in the photoelectric effect element experiment can be stopped by applying the voltage of 0.35 volts when the radiation is 256.7 nanometers used. Calculate the work function. Work function निकालना है. From the principle of conservation of energy, E is equal to the sum of the work function of the radiation and kinetic energy. So E equals to W naught plus KE. So W naught equals to E minus KE, and we know E equals to hc by lambda. putting in the values, we can calculate energy as 6.626 into 10 power of minus 34 into 3.0 into 10 power of 8 upon lambda is given 256.7 into 10 power of minus 9 meters. So it is equals to 7.744 into 10 power of minus 19 joules. Electron volts, we divided by 1.602 into 10 power of minus 19, it becomes equals to 4.83 electron volts. Now the potential applied is 0.35 volts, is kinetic energy. So work function equals to E minus KE. We calculated equal to 4.83 and KE is 0.35. So 4.83 minus 0.35 equals to 4.48 electron volts. That's the वर्क फंक्शन. तो दोस्तों इस वीडियो में इतना ही. अगर वीडियो आपको पसंद आया, अगर वीडियो आपके काम का था, प्लीज़ इसे लाइक करिए, चैनल को सब्सक्राइब करिए और इस वीडियो को अपने दोस्तों के साथ स्कूल में, कोचिंग में सब जगह शेयर करिए ताकि काम आ सके. मिलते हैं अगली वीडियो में और कुछ